All right, we're going to be looking at section 5.2. We're going to be looking at the sum and differences of angles and ask what's the sine or cosine of those results. So the idea is if I have two angles, I add them together, how can I figure out what the cosine is of the new angle in terms of the cosine and sine of the old angles? So what I'm going to do is I'm going to figure out the formula for this, and then I'm just going to state what the sine is for this as well as the cosine and sine if I have a minus instead of a plus. And the idea is I'm going to find two different ways to write expressions that involve sines and cosines of these things, set them equal, do some algebra, and then solve for this result. So the idea is this. The first thing I'm going to do is go back to the unit circle. So suppose I've got some angle here, we'll call that psi. This point right here is going to be cosine of psi, sine of psi. Suppose I've got another angle here. We're going to call this, say, minus theta. This point right here is going to be cosine of theta, and because it's in the fourth quadrant, it's going to be minus sine of theta. And so what I'm going to do is I'm going to find the distance between those 2 points. Okay? After I've done that, what I'm going to do is I'm going to take this figure and I'm going to rotate it up so that this thing right here goes along the x-axis. The angle between here will be theta plus psi. I'll find the distance between the new points using that relationship, set those two distances equal, and see if I can isolate this. And the answer is yes, because I know I can do it because I've done it already. So let's see. So what is the distance between here and here? Let's see, it's going to be the square root of this minus this squared. And now I've got to take this minus this, but this minus a minus will give me a plus. So there's my distance. All right, let me do this. I'm going to FOIL these out and try to simplify this as much as possible, because I know I'm going to have to use it later when I change this picture. So let's see, what am I going to get? I'm going to get the distance then. Let's see, this is going to be cosine of psi squared minus 2 cosine of psi cosine of theta, that's a psi, plus cosine of theta squared. So if I FOIL that out, I get this. And now when I FOIL this out, that's sine of psi squared plus 2 sine of psi sine of theta plus sine of theta squared. This is a big nasty expression. Let's see, first thing to note, cosine of psi squared plus sine of psi squared, that's the Pythagorean identity, that's just equal to 1. And this thing, cosine of theta squared and sine squared theta, if I add those, that's the Pythagorean identity again, and that's equal to 1. Okay? So let me do that. So this is going to give me 1. I'm going to leave that alone. This is 1, and then that I leave alone. Okay, and this becomes what? 1 plus 1 is 2, minus 2 cosine of psi, cosine of theta, is that minus correct? Yes, plus 2 sine of theta times sine of psi. Okay, so let me see. Let me replace that with that, because we need to come back and use that again later. So this right here, this expression, is equal to the square root of 2 minus 2 cosine of psi cosine of theta plus 2 sine of psi sine of theta. Okay? All right. So the distance between these 2 points is just that expression there. Now, let me take this triangle. I'm going to rotate it up an angle of theta so that this line right there is going to go over the x-axis. If I do that, let me just rewrite the whole thing. What's going to happen? So now I'm going to have this angle right there is going to be theta. Oops, let me keep it consistent with what I started with. So this is going to be psi plus theta. And let's see, this point right here is the point 1, 0. This point right here is going to be cosine of psi plus theta, sine of psi plus theta, because I'm working on the unit circle. And the distance from here to here has to be the same as that distance. Right? All I did was I took that same triangle and I just rotated it up. Even though it looks a little different, that's just my bad drawing. So what is this distance? This distance is going to be the square root of cosine of this minus 1. And I got to square the whole thing. And it's going to be sine of psi plus theta minus 0. Whole thing squared. Okay? So now I'm going to FOIL these things out, do some algebra, clean things up, and reduce it to make it as nice as possible. Once I do that, I'm going to set it equal to that. And then I'm going to try to solve for cosine of psi plus theta. And I know I'm going to get it, again, because I've already worked this out before I came over here. So let's see. This is going to be, if I FOIL that out, I'm going to have cosine of that thing squared minus 2 times 1 times cosine psi plus theta plus a minus 1 squared. And then this thing is just sine of psi plus theta, because if I subtract 0, it doesn't do anything. Okay. All right. Notice the Pythagorean theorem is going to save me again. This thing plus this thing is just 1. Cosine squared plus sine squared is 1, and these are the same angles. So this becomes 1 plus 1. I get 1, oops, careful, minus 2 cosine psi plus theta plus 1, and I already used that. Now the 1 plus 1, I get the 2. Get that expression. Okay, so this distance from here to here is also this, and it's also this. Okay, so notice I've got this expression inside here, and I've got this over here, so I'm just going to try to solve for that thing by itself, and I'll get a nice formula that'll tell me how to find the cosine of this in terms of cosine of psi, cosine of theta, sine of psi, sine of theta. So let's see what happens now. Oh. Erase that. So what did I have? I had 2 minus cosine psi plus theta. Actually, it's 2 minus 2 times that. Sorry. Double check. Yes. Is equal to that. Whatever that is. Okay. So let's see. The first thing I notice is I've got square roots. I don't like that. And I know both sides are positive, so I can just square both sides without too much concern. So then I get 2 minus 2 cosine psi plus theta this whole big mess, like so. Now, I can subtract 2 from both sides to get rid of that. I've got a minus 2 there. So I'm going to divide both sides by minus 2. If I do that, what do I get? I get cosine of psi plus theta. And the minus 2's are going to cancel. So I'm going to get cosine of psi, cosine of theta. I've got a plus divided by a minus. 2's cancel. Now I get that expression. Okay? So the cosine of the sum of two angles is the cosine of the first times cosine of the second minus sine of the first times sine of the second. Okay? Now I can go through and do this in various different ways. And if I do, I can derive these different ones. I'm not going to do that. So just hope you can trust me. Now I've got to be careful about the order of these things. It's going to turn out that the sine of psi plus theta is going to be sine of psi cosine of theta plus cosine of psi sine of theta. So oftentimes you say cosine is unfriendly because it has cosines and sines that are segregated. Sine is friendly because they're all mixed up. Likewise, I take cosine of psi minus theta. I get cosine of psi, cosine of theta, plus sine of psi, sine of theta. So you can think of this as this minus theta. Cosine of minus theta is cosine of theta because it's an even function. Sine of minus theta is minus sine of theta because it's an odd, so that comes out. And likewise, for the same reasons, I take the sine of psi minus theta. I get sine of psi, cosine of theta, minus cosine psi times sine of theta. Okay? All right. So I'm going to do an example of one way we might want to try to use this. Okay? So, we now have this expression. So for this example, what do we have? We have this up. We need a little more room here. I know what's the cosine of arcsine of 0.3 plus the arctangent of 0.7. Okay? Now the thing to recognize is the arcsine of something is just an angle, so let me call that my psi. And the arctangent is another angle, I'm going to call that theta. So I'm just going to plug straight into this expression. I'm going to have the cosine of this times the cosine of that minus the sine of that times the sine of that. Once I get that broken out, I'm going to go back and use all that triangle stuff we've done before, and I'm done with that. Okay, so let's see. This is going to be the cosine of psi times the cosine of theta minus the sine of psi times the sine of theta. Okay? And now I've got to figure out what that is. So again, right, this is some angle psi, that's some angle theta, and I don't really care what those angles are. What I care about is what's the cosine and the sine of those angles. So now I'm going to switch gears, turn around, and think about what does this mean in terms of right triangle trig. Right, so this is just like the stuff we've done before. So let me call this angle psi. Let me call that angle theta. And what do I know? I know that the sine of psi, so if psi equals arc sine of 0.3, if I take the sine of both sides, sine of the arc sine is 0.3. So I know the sine of this angle is 0.3. So that sine is opposite over hypotenuse. So I'm just going to call this 0.3, and I'm going to call that 1. What do I know here? I know that the tangent of theta is 0.7. So what's tangent is opposite over adjacent. So I'm just going to arbitrarily decide to call that 0.7 and 1. So what's my missing sides now? This is going to be 1 squared minus 0.3 squared, Pythagorean theorem, and this is going to be the square root of 1 squared plus 0.7 squared. So now coming down, cosine of psi is going to be 1 minus 0.3 squared over the hypotenuse, so that's adjacent over hypotenuse. Cosine of theta is going to be 1 over square root of 1 plus 0.7 squared, because 1 squared is 1. And I'm going to have a minus sine of this angle is going to be 0.3 over 1. And then, let's see, the sine of this angle is going to be opposite. Oops, let me clean that up. Over hypotenuse.